substitution. Again, and what I'm going to typically do is really do more of just the trial and error and really just showing you guys how to do it. Okay, and you guys are going to, and what we're going to do a little bit more is we're going to use the whiteboards a little more than we did in the last couple weeks too. Not necessarily today, maybe tomorrow we'll do a little more of the whiteboards. Okay, so we have this system of equations. Let's see if we remember what makes up a system. How do I even know that what I have on the board right now is a system? Bailey, what, you had a question, honey, or just a comment?
There was a question.
Okay, yeah.
Have you earlier said syllabus then?
Yep.
Okay.
Yep. Or not syllabus, you mean pacing guide?
Yeah.
Yes. Okay. Class, tell me right now, how do I know that is a system of equations? How do I know it's a system? Let's make sure we put that back in our notes. How do I know it's a system?
It's that equal.
Yeah. Say it again, Bailey.
It's that equal to something.
It's set equal to something. Well, you're close, but not really what I'm looking for. Let's see if let's try it again. How many equations do I have up there? Two. So you know what the definition of a system of equations is? It has to have two or more equations. Right, let's put that in our notes, okay? Remember that a system, okay, has two or more equations in the same variables. In the same variables. Okay? So a system is defined as, oh, hi Ashley. Oh, your humidity test. Yes, go ahead. What do you need to do? Okay? They're just doing some humidity test, guys, for science class, and they need to do it over the course of 3 days. Jack?
Is that 8y minus 3 or plus 3? I can't really see it.
Y minus 3.
All right.
X equals 8y minus 3, Jack. Good question. Okay, so we have this system of equations, class. We have these two equations, and obviously it's a system because we have two equations. Notice notice the first equation, the top equation. What is that equation set equal to? X, right? Now, what did we know about substitution? In order to use substitution, we have to have one of the two equations set equal to either x or y. Exactly. So if I look at this equation, or look at this system, the top equation is solved for x. So therefore, I can use substitution to solve for my other variable y. Now, this is what I want to do. I want to use a different color. Again, you guys don't have different colored pencils, obviously, or anything like that in front of you. But I want to show you. I'm going to take, since x is equal to 8y minus 3, I then can replace x with the expression 8y minus 3. So I'm going to take my purple here. I'm going to identify what x is equal to. That expression 8y minus 3 is then going to take the place of x. In the what equation? The first or second? The second equation, exactly. So I'm going to take this 8y minus 3 and find x in the second equation and replace x with 8y minus 3. Because I cannot solve an equation with two different variables, can I? Okay, so I'm going to take this right here, and it's going to go in for this x right there. So I'm going to replace x with 8y minus 3. Okay? So let's see what it looks like now, class. So we've got 3. And then obviously, guys, if we're replacing x with 8y minus 3, what do I need to make sure I put 8y minus 3 in?
Parentheses.
Say it a little louder, Tony. Parentheses, perfect. So I'm going to go ahead and put 8y minus 3 in here for x. So 8y minus 3 minus what? 4y is equal to? 1. Good. And now, obviously, in order for me to eliminate the parentheses, what property do I need to use? Distributive property, exactly, distributive property. So what's 3 times 8y? 24y. Minus, what's 3 times a negative 3? Negative 9. What else do I bring down? Negative 4y equals 1, exactly. Now I've got like what? What do you see?
Terms.
Like terms, exactly. What's 24y minus 4y? 20y. Mrs. Topis, can you see this okay with a red?
Yep.
Okay, good. I just didn't know if you can see it. All right, now I've got an equation I can solve here. What do I need to do to both sides now?
Add 9.
Add 9 to both sides. Perfect. I get 20y equals 10, and what do I do to both sides?
5 by 20.
Divide by 20. Good, Tim? Yep, Jack, I'm hearing a lot of good answers, guys. Y equals, what's 10/20ths in lowest terms?
1/2.
1/2. So I've got y is equal to 1/2. Now, let's put this down in our little tidbits of information over here about some things we need to know from this lesson. What do I know that all of my answers should be when I solve a system of equations? What do all my answers need to be? Ordered what? Pairs. Let's put that down in our notes. Solutions to system of equations are ordered pairs. Okay, usually in what two variables? Usually x and what? Y, right. Right now then, class, yes, Bailey, go ahead.
Why did we add 4y to the other 4y?
Because it's a minus 4y right here, Bailey. So if I have 24y minus 4y, if I combine like terms, 24 minus 4 is 20, not 28. If this was a plus 4y, yeah, then we would have 28y. But because it's minus 4y, we got to take and combine those like terms. If you want to change this to plus and negative, obviously, then you can see it that way as well. Bailey, does that help? Okay. So we've got half our answer. We've got our y coordinate of our ordered pair, our solution. How do we get our x?
Plug it in.
Plug it in, exactly. Which one of these two equations would you suggest would be the easier one to plug in y and solve for x? The top or the bottom? The top, exactly. So now let's go ahead and plug in x equals 8 times y. What is y now? 1/2 minus 3. X equals, what's 8 times 1/2? 8. 4, right? Yep. 8 times 1/2, not 8 plus 1, or minus 1/2. And then minus 3. What's 4 minus 3?
1.
1. And now we have our x coordinate of our ordered pair. Now there's one more thing we need to do. What is it? Check. Who said that? Very good, Esme. We have to check our answer, don't we? Once we get our ordered pair, once we get our 1/2 as our possible, let me say that again, possible solution, I do not know for sure whether that answer is correct until I check it. All right, so let's go ahead and check our answer. So now we're going to check it. We're going to go x, in this case, x is 1. So 1 equals 8 times what, class? 1/2 minus 3. So these two sides better equal each other. And remember, our rule is, let's put this over in our bits of information over here. Remember, when we check our answer, or check our possible solution, it has to work for what?
Both.
It has to fit for both, right? It has to be true. Now this is what I'm going to say. This is actually the wording I want you to use. It has to be true for all the conditions of the system. It has to be true for all conditions of the system. Which means, guys, it has to fit for both equations, is really what it's saying. Okay? Alright, so let's go ahead and see if it works. 1 equals, what's 8 times 1/2? What's half of 8?
4.
4 minus 3. 1. Does 1 equal 1? So that one checks. Let's do the second equation. Remember, it has to work for both equations of the system in order for it to be a true solution. 3 times x. What's x? 1. Minus 4 times y. What's y? 1/2 has to, yes, equal 1. Sorry. Okay, what's 3 times 1? 3. What's minus, what's 1/2 of 4? 2. Is 3 minus 2 1? So therefore, do they both check? So therefore, do we have a solution to this system of equations? Yes. All right. Okay, let's do